This is just a different method for dividing polynomials. So we'll work through an example and I'll explain the process as I work through an example. Okay, here's the first example, x to the fourth minus 10x squared minus 2x plus 4 divided by x plus 3. Okay, make sure you skip a line, and then we're going to draw a symbol that's similar to the long division symbol, but it's just more square, that's it. This is what we're going to use to help us organize our numbers. Okay, so on top of this line, we're going to kind of write ourselves a guide, starting with x to the fourth, because that's our biggest exponent. Just like I said when we were learning long division, whatever your biggest exponent is, you have to have every exponent stepping down from that represented. So we're going to start with x to the fourth, then we'll need x cubed, then x squared, then just x, and then just a number, a constant. We'll use c to represent that. So this just gives us a starting point, and then also make sure that we're not going to forget any placeholders that we might need. Underneath each one of these, we're going to write the coefficients of each of these terms. So in our expression up here, x to the fourth just has a coefficient of 1. There's not a number in front of it written, and when that's the case, it's understood to be 1. So we're going to write 1 just below x to the fourth. X cubed, we don't have an x cubed term in our expression, so that means the coefficient for x cubed is actually 0. That's our placeholder. For x squared, the coefficient is -10. Okay, so you have to include whatever the sign is in front of the coefficient as well. So for x squared, we have -10. For x to the first power, or just x, we have -2 as our coefficient. And then our constant is just a +4. Okay, on the other side of this line, we're going to use what we're dividing by, which is x plus 3, but we're not going to write x plus 3. We're actually going to take the opposite sign of this number. So instead of a +3 like we have here, we're going to use the opposite, which would be -3. Okay, last thing we do is we skip a line underneath these numbers, and then we draw a line. Now we've got our problem set up how we need it. Now we can actually do the math. Okay, first step, we're going to take the first number, whatever it is, and we're just going to bring it down below this line. Nothing changes about it, we just bring it down. Any number under this line gets multiplied by -3. So we're going to do 1 times -3 to get -3, and that gets written right there. Then we combine each column. And by combine, you can think of it as addition. So don't get this confused, because in long division, kind of when you get to this step, you subtract. So in synthetic division, we're adding these numbers together. 0 plus -3 is -3. So this -3 is below this line. That means it gets multiplied by this number up here, which is also -3. So -3 times -3 is +9. Add each column. So -10 plus 9 is -1. -1 gets multiplied by -3. -1 times -3 is +3. Then we add. -2 plus 3 is +1. Multiply. 1 times -3, we get -3. And one last time, we add 4 plus -3. That's the same as 4 minus 3, which is 1. What we do with this very last number that we've written, we kind of box it in, kind of keep it separate from the rest of the numbers, because that's actually our remainder. Okay, so let's recap. Let's write a few notes so that when you look back at these notes, you can understand what's going on. So we start with the biggest exponent. And step down. So we started with x to the 4th, then we went to x cubed, x squared, just x, and then just a constant. That's how we got those. And that was just a guide to help us know where to write each coefficient. So these numbers are the coefficients of each term. Then we went up here to the whatever we're dividing by, x plus 3. We used the opposite sign. So because it was a +3, we used -3. Okay, then our steps kind of went like this. Bring down the first number. We brought down this 1. We didn't do anything to it. We just brought it down. Then we multiply by the divisor. It just means you multiply by whatever you're dividing by. It's kind of odd how that works, but that's how we do it. Add each column was our last step. And you kind of, the whole way through, you're going back and forth between step 2 and 3. Multiply, then add, then multiply, then add, then multiply, then add until you're finished. Now we get to write our answer. So we're going to start, let's make a note here, start with 1 less than the biggest exponent. And these numbers in our bottom row become the new coefficients. Okay, so what this means, start with one less than the biggest exponent. That means our original equation had x to the fourth. We're going to start with one less than that using x cubed. And this row becomes our new coefficients. So this first term, this 1, is our coefficient for x cubed. And when you have 1 as your coefficient, you don't really have to write it the same way we had x to the fourth. So we're just starting with 1x cubed, and you don't have to write the 1. Then we have a -3 next, so we have minus 3x squared. Then we have -1, so minus 1x, and since my coefficient is just 1, I don't have to write it. I just put minus x. Next, we have a +1, and that's our constant. So we have +1. And then we're going to write our remainder, which we boxed in, the same way we wrote the remainder from the last example in our long division notes. So plus, and then we take our remainder and we write it as a fraction using our original divisor as the denominator. So we have +1 over x plus 3. So the remainder goes in the numerator. We use whatever we divided by originally as the denominator. And this is our answer. It seems like a long process because I took it slow so that I could explain every step to you guys. But I like synthetic division better. Once you get used to the process, it seems quicker to me. And honestly, it's a lot less thought. It's just you follow the procedure and then you get to the answer. You don't really even have to do that much math, which could be a good thing or a bad thing, but it works. Okay, so let's do another example and try to move a little bit quicker. One thing I do want to mention before we keep going is in order to use synthetic division, whatever we're dividing by, which in this example was x plus 3, this x has to just be x. It can't be 2x, it can't be x squared, it can't be anything besides x in order to use synthetic division to divide. So our second example that we worked using long division, we divided by 2x minus 1. So there's no way that we could use synthetic division for that example because it's not just x. So just something to remember. All right, let's do another one. I'll give you guys a second to get that written. 4x to the fourth minus 2x squared minus x plus 1 divided by x plus 2. Okay, let's get this set up. Draw our symbol here. And then remember, we start with the variable that has the biggest exponent. So in this one, it's x to the fourth again. So we start with x to the fourth and we step down from there. So x cubed, x squared, just x, and then a constant. Okay, so we write the coefficients of each term underneath. The coefficient of x to the fourth is 4. The coefficient of x cubed, well, there's not an x cubed, so that coefficient is 0. It's the same thing as the other example. Coefficient of x squared is a -2. The coefficient of x is -1, and our constant is a +1. And since we're dividing by x plus 2, we use the opposite sign. So we're using 2, but instead of a +2, we're using a -2. Skip a line, draw a line, and we're ready. Okay, first step, bring down this first number. So we're bringing down this 4 below the line. And since it's below the line, it gets multiplied by -2. 4 times -2 is -8. Then we add 0 plus -8. That's the same as 0 minus 8. We get -8. Then we multiply again. -8 times -2 is +16. Add -2 plus 16 is 14. Multiply 14 times -2 is -28. -1 plus -28 is -29. Multiply -29 times -2. You can use a calculator for that if you need to. We get a +58. Add 1 plus 58, we get 59. And remember that last number in this row is going to be our remainder. So we box it in just to keep it separate from the rest. Okay, now we're ready to write our answer. So remember, we're using this bottom row as our new coefficients, and we start with 1 less than the exponent that was biggest in the beginning. So our first coefficient is 4, and that's on x cubed, minus 8x squared plus 14x minus 29. Then we have our remainder of 59. So we do plus 59 over x plus 2. So remember, the remainder goes in the numerator. Whatever we divided by initially goes in the denominator. And that's our answer.
Wait, Ms. Fulmer, I'm confused on something.
Sure.
Okay, so the 4 below, if you go, it's above x to the 4th power. So why would it not be 4x to the 4th power in your answer?
Because our answer, these numbers, the x to the 4th, x cubed, x squared, x, and the constant, just helps you get the problem set up.
Oh,
That
okay.
you can basically ignore them. And then,
Oh, okay. I see now.
Yeah.
Okay, got
you're good.
Rid of the x to the fourth. But we had it at the beginning, and then like you just done.
Yeah, if you think about it in terms of the long division that we did, we're basically doing x to the 4th divided by x.
Oh, okay. So
And x to the 4th over x, if you think back to when we did multiplying and dividing monomials, if we were to do x to the 4th divided by x, 4 minus 1 is 3, so we end up with x cubed. So it should make sense that whatever our answer is
yeah.
has 1 less x in it than the initial problem.
I know you're getting the lesser number anyway.
Yeah. All right, let's do one more example before I give you guys some practice problems. Okay, 3x cubed minus 17x squared plus 15x minus 25 divided by x minus 5. So let's get this problem set up. And honestly, you don't even really have to write those numbers above this line. It helps me, at least, to make sure that I don't miss a placeholder. So like if I hadn't written these numbers, it would have been really easy for me to just copy down these coefficients for -2, -1, and then the constant. But then I would have been missing this placeholder for x cubed. And if you can think about it enough to not forget the placeholder, that's fine. You don't really have to write those numbers. It just helps with the setup a little bit. So I'm going to keep doing it.
You forgot the first step. You gotta check to see if there's something in front of that X.
Oh, yes, that is, yep, good point. Robert reminded me to make sure that there's not a number in front of this x. Because if there was, we couldn't use synthetic division. We would have to use long division. There's not, thankfully. And our biggest exponent this time is 3. So we have x cubed, x squared, x, and a constant. So let's write our coefficients. Coefficient of x cubed is 3. Coefficient of x squared is -17. Coefficient of x is +15. And our constant is -25. Okay, we're dividing by x minus 5. So we're going to use the number 5, but the opposite sign. So instead of -5, we're using a +5. Skip a line, draw a line, and we're ready to start. Bring our first number down below the line. Then multiply. 3 times 5 is 15. Add each column, so -17 plus 15 is -2. Multiply, -2 times 5 is -10. Add 15 plus -10, that's the same as 15 minus 10, which is 5. And 5 times 5 is 25. Add -25 plus 25 is 0. That is our remainder. Finally got a remainder of 0. Yay. So in our answer, these are our new coefficients, and we're starting with one less exponent than we started with originally. So 3x squared minus 2x plus 5. Our remainder is 0. There's no reason to write plus 0 over x minus 5 because that's still just 0. So if your remainder is 0, you don't have to do anything else. This is your answer.
How many questions on the card?
Either 6 or 8, I can't remember.
I knew it was gonna be another 20 piece.